Hey guys, welcome to CodeChef's YouTube channel. The problem that we're going to discuss today is wildcard replacement. The problem appeared in November 21 long challenge and has a difficulty level of easy. The prerequisites to solve this problem include dynamic programming and stacks. The problem statement goes as follows. We are given a string S whose characters has one of these 5 characters, that is opening and closing bracket, plus, subtraction and question mark. Okay, so our string is given as follows. It means that only these characters will be present in our string. So what is a valid string? A valid string is it consists of either a single question mark, or it consists of two valid strings that are appended using a plus symbol or using a minus symbol. Okay, so x plus y or x minus y, where x itself is another valid string. It could be as complex as possible. So some examples of valid strings are given over here. You can see them. Now it is defined that a power of valid string is the maximum value attainable by replacing each question mark by a 0 or a 1. Okay, so each question mark in the string, if we replace it either by a 0 or 1, then whatever is the maximum value attainable, that is the power of a valid string. So if you take this small example, say question mark minus question mark, the power of the string is 1 because the maximum value that we can have is 1 minus 0, that is 1. Okay, so what is the question now? The question is that we are given a valid string S. So we will be given a long string S that which is guaranteed to be a valid string, and we will also be given some queries along with it. So Q queries are given. Each query is represented by two integers L comma R. Okay, and we have to find the power of the substring SL to SR, meaning that we have to take the Lth character, we have to take the Rth character, and then whatever is this substring, we have to find the power of this string. Now it is also guaranteed that the given substring, that is from L to R, is a valid string, okay, according to these rules. So you don't have to worry, all the queries that will be given, they will be valid strings. So you can evaluate them by putting question marks as either 1 or 0. You will always get some answer. So all the brackets are going to be balanced in that string and so on. So this is basically the question. One thing to note is that the input of this problem is going to be large. So we have to use fast IO methods in the implementation. In whichever language you are using. If you are using C++, you make sure that you see what methods are used for implementing fast IO. And similarly for other languages like Python and Java as well. So with this, I think the problem statement is pretty clear. We just have a big string. In that we'll be given a substring, rather many queries that account to a substring, and for that substring we have to find the power of the string. What is power of the string? It is the maximum value attainable by replacing each question mark by either a 0 or 1. So for example, if someone gives a string like this, question mark plus question mark and again one more question mark, so the maximum value attainable over here is 3. Why? Because we can just replace all of them by 1. So 1 plus 1 plus 1, that is 3. So that makes the question clear. Now let's see the solution approach. So the solution approach goes as follows. Our idea is going to be simple. We are going to try and find the answer for the whole given string, and in the process we are going to get the answers for all possible substrings. Now you might be wondering, how is this possible? Because we are going to use a concept known as dynamic programming. So in this process, we are going to actually find the answer for each possible index as the ending index of the string. Okay, and that is going to do the trick. So before we start, we need to know that each element in this string is going to belong to either of the one halves. That is, maybe I can call them a plus half and a minus half. Okay, and how do I decide which element, which half the current element belongs to? Basically, we parse this given string and we keep a track of the brackets and the addition and subtraction symbols, and with that we can tell that which half the current symbol belongs to. How? Now, if you see the current string that I have drawn, imagine a plus sign over here outside the whole string. So the plus sign is applicable on this first element, on this first symbol, on this second symbol, on this third symbol. Once I have seen this negative or subtraction symbol, my sign gets flipped. So my sign becomes negative. Okay, sign became negative, and then after that, as soon as I encounter a closing bracket, okay, as soon as I encounter a closing bracket, I revert back to the sign to its corresponding opening bracket. So the corresponding opening bracket had plus sign. So I will paste the same sign over here. Okay, the same sign is pasted over here. In similar manner, I continue. Then the effect of this minus is now propagated. How is it propagated? This will become minus, this will become minus, and whenever I encounter a minus sign, the current ongoing sign gets flipped, so it becomes plus now. Okay, so it became plus, and again when I encounter a closing bracket, I search for its corresponding opening bracket, and whatever sign it had, I just keep the same sign over here. Okay, so we got the halves for each element. Now that is, now I know which half the current element belongs to. How is it going to help me? It is going to help me in the sense that I now know what element needs to be replaced by 1 and what element needs to be replaced by 0. So the question marks can either be replaced by a 1 or a 0 as per the question. And with this info, I now know that what question mark should be replaced by a 1 and what should be replaced by a 0. And how is that? Let's see. So only the question marks are going to be replaced. So the other symbols like opening and closing brackets, they don't make much sense right now. Their part is done because we have already pre-computed the halves for each element. Okay, so the halves for each element are pre-computed. Now what we have to basically do is, whenever we encounter a plus sign, okay, so I have drawn a plus over here. Okay, oh sorry, I just erased it. Yeah, so I have drawn a plus over here and a minus over here. So whenever we see that the current symbol has a plus sign, we will add 1 to the plus array. Whenever we see that there is a minus sign, we will add 1 to the minus array. Okay. And what that will do is basically it will store the maximum possible sum ending at that index. Okay. From the beginning of the string. So in the beginning, we have zeros over here. Then again, we have a question mark. Okay, so we have a question mark over here, but the sign is plus. So we increment by 1 over here. The below one remains as it is, 0. And one more thing, when we are filling this array, we will make sure that we are also taking prefix sums. Now you might be again wondering why we are taking prefix sums. Can't we just add 1 where all the plus are present, like here plus is present, so here I will write 1. No, if I do that, the effect of this one won't be propagated forward. So why I am taking prefix sum? I will be taking prefix sum because later on I have to answer the range queries. That is queries like L comma R. That is, I can be given any substring and I have to give the answer for that possible substring. So in that case, what I will do? I will take the answer for the ending index and subtract the answer for the L index. Okay. So answer of R minus answer of L will give me the final answer. So that is why we are taking prefix sum. This is a pretty well-known technique in dynamic programming. So yeah, so this one will persist over here. Okay, and here we have 0 because um, the signs over here are plus. Okay, then we got a minus over here. So once we got the minus, I will put a 1 over here. Okay, and this remains the same. The plus array is not getting updated. So this is an array. Okay, these both are array. Oh, not 0. It will be 1 only because we are taking prefix sums. So unless and until a new one is added, the previous sum will get on propagating. So because this is a bracket, nothing gets changed over here. nothing gets changed over here, nothing gets changed over here. Similarly, in the minus array also, nothing gets changed over here. Okay, so let's continue our process. In our process, then now for the current question mark, we have a minus symbol. So we will be adding 1 to the existing sum. So 1 plus 1 becomes 2. Okay, so it became 2 over here. It still remains 1, 1 because all these symbols are minus minus. Okay, and this 2 also gets propagating. And here we have a plus symbol. So 1 becomes 2. Okay, and this 2 remains 2 as it is, remains as it is, remains as it is. So we have got the prefix sum arrays with us. Now, how to use these arrays to our information? Remember how I told that each element belongs to some half, that is either the plus half or the minus half. So that halves array will be storing the optimal sum or the maximum possible value of the expression till that point. Okay, so if someone asks you that what is the maximum possible value of this whole expression, okay, so what we will do, we will take the extreme indices, these are the indices, and for this index I will see, okay, this index belongs to the minus half. Okay, why minus half? Because we had earlier pre-computed that is the same sign as the opening bracket. Okay, over here, so I take the value from here, because it is minus, I take the value from here, that is 2, and because this is the leftmost index and it lies in the plus half, I take the value from the plus array, and I have to just subtract these both, that is 2 minus 0, that is 2, and that gives me the maximum possible value of this whole string. Okay, this is for the whole string, but remember, we will not be always given the extreme indices. We can also be given some substring in between. Okay, condition applied that it should be a valid substring. For example, we can be given a substring like the substring can be only this much. What if the substring given is only this much? I still know that if I began with the plus symbol and I kept on classifying the elements into the possible two halves, that is the plus half and the minus half, I know what is the half for the ending element. Okay, so these are my extremes now. This is the L, this is the R. I go at the minus half value of R, that is you can see over here, that is 2, and I subtract the value of the starting index, that is L, which is also belonging to this minus half. So there the value is 1. So 2 minus 1, the value is 1. So it is correct. Why? Because if you see this string question mark minus question mark, it can be replaced by 1 minus 0 to get the maximum value of 1. As you can see, there is no other way to get the maximum value as 1. So what we did was we pre-processed the whole string in such a way that now we have the answers for all possible substrings. And how did we do that? Simply solve the question for the whole string. So if you have to solve the question for the whole string, this is the way you would have solved, right? Assume that there is a plus symbol in the beginning of the whole string, an imaginary plus symbol. Okay, and then as per the brackets and the signs given, keep on flipping the sign of the current element, and whenever you encounter a closing bracket, just switch to the sign of the corresponding opening bracket. So here we switch to the plus because the opening bracket sign was plus. Okay, and that's it. Once you have that, once this once you get what half the current element belongs to, we can simply maintain two arrays, and according to the half of the current element, we can increment the corresponding array. And also don't forget to take the prefix sum. So here we are taking prefix sum, that is because this question mark is getting replaced by 1 in the plus array, 1 plus 1 equals 2. So the prefix sum is being propagated. Okay, why? Because We don't want to take the sum again and again for the subarray. That is why once we have this array computed, if someone gives us the substring L comma R, we can directly say the answer is going to be whatever is the answer at R minus whatever is the answer at L. So answer at R is the corresponding sign's answer number, and the answer at L is whatever is the corresponding sign over L, that answer. Okay. So in this manner, we can solve this problem using stack. So one more question that might arise in your mind is that how do you check which is the opening bracket of the corresponding closing bracket? So for that, we will just use a stack. So whenever we get an opening bracket, we will put that into a stack. Whenever we get a closing bracket, we will pop that. In this manner, the corresponding bracket's position is known to us. So that will be helpful in the implementation. So that is why along with DP, stacks is also required in solving this question. So you can see in this example, because we have calculated both these arrays, you can try checking for yourself, like take some small substring like this and find the answer. You will see that the answer is 1 minus 0, that is 1. You can also take the whole string as the query and then find the answer. Okay, so that is the basically solution approach for this question. It will be more clear once you see the implementation. So the implementation goes as follows. We start by taking the input, that is the string input. I calculate the length of the string, and then I have a vector bool array which stores the current half of the element. So there can be only two halves, as we just saw, plus and minus. I am just showing them by boolean variable, that is true or false. Okay, so true corresponds to plus and false corresponds to minus. Or you can even do an vector of int with 1 or 0 as the halves. Okay, so the current sign or the current half is true because that is what we had set over here, an imaginary plus, okay, before the whole string began. And then I just iterate over the whole string. I also have a stack for helping me with the opening and closing brackets. So I iterate in the whole string. Whatever is the current state is the current half of the element. Okay, so whatever is the ith element, the current state is its half. Okay, but what are the changes we need to take care of if we encounter a closing bracket? The state of the element or the half of the element is corresponding opening bracket. So the corresponding opening bracket's position is stored in the top of the stack. Okay, so we can take it from there. DP of I is basically DP of stack top. And once we have that, the pair is complete, the bracket pair is complete, we can just pop the bracket index from the stack and we can just continue. Okay, and another thing you need to take care of is that whenever you encounter an opening bracket, you need to push it in the stack, because how else would you get it in the stack top in the for this condition? Okay, and that being done, once you get the minus symbol, make sure to flip the current half. That is, as you saw, when you get the minus symbol, plus gets changed to minus. And if it's already minus and you encounter another minus, minus minus becomes plus. Okay, so that way the halves are getting switched. And a good way to do that is just using XOR equal to. This is just acting as a toggle between true and false. So if the current value is true, it will become false. If it is false, it will become true. After that, I have my pre-computation array. As we saw here, we have two arrays with us. The same two arrays are denoted over here with the name pre. So it is a 2D array. And then 0 and 1 is basically, this is basically the minus half, and this is basically the plus half. Okay, so 1 denotes dp of I is true, 0 denotes that dp of I is false. So every time, independent of the value of dp of I need to take the prefix sum. So that is why I just blindly do plus equals to the previous element in that array. So pre of I0 is plus equals to pre of I minus 1 0. So that is done independent of the DP state. And then if the current DP state is 0, then I increment that. If it is 1, I increment that one. As you saw over here, if it is a plus, I only increment the plus one. If it's the minus, I increment the minus. So 0 became 1 over here and 0 became 1 over here. Similarly, if you see over here, the state was minus, so I only incremented the minus 1. Okay, the minus array. And that way I pre-compute the whole prefix array, prefix sum array, and then I have to just output the answer based on the input. So I get q queries. For each query we have L and R. So some of you can make the mistake over here that the input given is in 1 based indexing, okay, and everything that we are doing till now is in 0 based indexing. So make sure to decrement the given indices by 1 each. So L minus minus R minus minus ensures that we have everything in 0 based indexing now. After that, if L equals R, and it is guaranteed that every given query is a valid string. So if L equals R, it means that the string is just a single question mark. So you don't need to actually worry. Just a very well-known case, just output the answer as 1. Okay. Or else the answer is what? Whatever is the answer at R. So pre of R and the state is dp of R minus pre of L, the state is dp of L. So that's what we saw, right? Answer of R minus answer of L. But what is answer of R? At index R, see the current half it belongs to and pick up the value from that array. Okay, that prefix sum array. So that is done over here. And just output all the query answers in a single line. And don't forget that we have to output them space separated because that is being asked in the question. And after each test case, we have to give a new line. So this basically completes the implementation. And let's now submit the code on CodeChef ID to test our correctness. So let's copy and paste the code, change our language to C++17 and let's submit the code. Great, so our solution works. The complexity for this implementation, if you have guessed rightly, it is going to be order of n for the pre-processing, right? Because assuming there are n characters in the string, that is the string length is n. We are just iterating over the string twice. Once for calculating which half the current element belongs to, and another for calculating the prefix sums. And after that, for each query, we are just answering it in order of 1. So it is safe to say that the time complexity for this question is order of n plus q, where n is the length of the string. And what is q? Q is basically uh, actually not order of n plus q, order of n for the pre-processing and order of 1 for each query. We can say that. Okay. So that being said, brings us to the end of the solution. I hope you guys understood this explanation. If you have any doubts, you can post them in the comments below. I'll try to answer as much as I can.